Okay, hi. So my name is John Mulligan. I work for IBM. I've been spending my recent work hours developing some of our new SMB features for Ceph. So, once again, so I've been working for IBM for a while now. I had been on the Ceph and ODF team at Red Hat when we came over. And then earlier this year, I was happy to be able to join the Samba team upstream project organization. So I'll be covering what we've been doing in our work, adding SMB support to Ceph. And this all covers our upstream development efforts. First of all, I want to introduce the concept of SMB on Ceph. What does this mean? We're all here at Cephlicon. I figure most of us know what Ceph is, so I'm not going to do a deep dive into Ceph. You do get some bonus points if you've ever used NFS on Ceph, because a lot of this stuff should be very similar. I do want to mention that our integration with Ceph covers CephFS and only CephFS. Now, if you're still here and you're still interested in this topic, I will talk a little bit about SMB, which is a very common network protocol for file sharing. This is the native protocol for Windows. It's also well supported by OS X and Linux. I told myself I wouldn't say OS X, it's OS 10, but I did it anyway. So SMB has been around for quite a long time. SMB 1 is largely gone at this point, unless you're really into retro computing. SMB 3 is the protocol that we're going to be talking about today. And then finally, Samba is the upstream project that implements SMB and a bunch of tools to integrate with the SMB and Windows ecosystem. SMB on Ceph means that we're integrating SMB support into the Ceph project. What we want to do is provide a workflow that uses the native Ceph tools, create a system for developing or creating consistent deployments. We want to benefit from our use of Ceph ADM's orchestration layer, and then we want to coordinate with other parts of Ceph, largely CephFS. Of course, this isn't a new concept. People have been running Samba on Ceph for quite some time. What we're doing is taking what the existing building blocks were in the ecosystem and kind of bringing them all together. There was some documentation out there, instructions, blog posts, people writing things saying, you know, run CephFS on this node, set up Samba this way. But the documentation was largely dispersed, and there weren't a lot of best practices out there already. There was also some lack of maintenance in various components. In particular, we decided to help revitalize the VFS CephFS module. In addition to Ceph, our team has been working with other upstream projects that exist kind of between the Samba ecosystem and other components. Now, I don't want to spend too much time on this slide, but I do recommend that you can download the slide and click on the links. But the important thing is we have a little umbrella organization that we have called Samba and Kubernetes. However, Kubernetes isn't really involved in this work, but we had originally started writing a Samba operator. We don't use it in our Ceph integration, but it served as an inspiration for a lot of the development effort once we started working directly in Ceph. Our orchestration work involved adding a whole bunch of stuff to the Ceph ADM orchestration. Because we had been using init containers and sidecars in our Kubernetes work, we decided to add these concepts to Ceph ADM. Once Ceph ADM could support these, we were able to develop a SMB service spec so Ceph ADM could deploy our containers. And then we had to do a bunch of other low-level work to get it all glued together. On top of that existing orchestration, we developed a new SMB manager module for the user to interact with. This can be compared directly to the NFS module. This module provides an interface for the users to have CLI commands and should eventually serve for some dashboard integration. This module uses Ceph orchestration to do the deployment. There are two major concepts within the module, which is clusters and shares. Clusters is almost a direct one-to-one of the NFS cluster concept. These aren't necessarily true clusters. They're logical clusters that might consist of just one node. Shares are equivalent of NFS exports and are the primary thing that users will be accessing their data from. Unlike NFS, we have to have Active Directory support right out of the box because we predict that this will be one of the major use cases for SMB. So we have some additional things in the module to do Active Directory integration. Our container image is pretty simple. We take Samba packages, then we combine them with the Samba CC project, which provides an entry point and libraries for easing the use of Samba in a container. And we all put that together in a CentOS base image. Once we're deployed, we typically will have an SMBD, that's the primary container on all of our deployments. And then depending on your configuration, you might have WinBind for Active Directory integration. You might have CTDB for true clustering. And there are some other sidecars that will appear in the system. There are two sets of commands that the manager module provides. The two categories are imperative commands, which are very similar to those that already exist in the NFS Manager module, where you say things like create a cluster, create a share, remove a share, etc. But we also developed a declarative resource style, where very similar to the existing Ceph ADM service specs, or something like a Kubernetes resource, you tell the cluster, this is what I want things to look like, and it'll try and make it happen. These are applied using a Ceph SMB apply command, and the resource types that we work with are cluster, share, as mentioned before. We also have join authentications, and a users and groups resources for clusters that aren't joined to Active Directory. Despite putting these in two different categories, they are fully compatible with each other. So you can create a resource with cluster create, delete it with SMB apply. You can create something with SMB apply and remove it with share RM. So now I'm going to start approximately 14-minute demo. Hopefully we have sufficient time for everything. I do want to mention that this demo was created on a small 5-node cluster. These were all running in virtual machines. I had already set up an Active Directory domain controller using the Samba DC support. And I have a Windows client and a Linux client ready to go. All of this stuff is currently based on Ceph's main branch and the containers that are being built off of main. So if you could start the demo recording, please. So the first thing we're going to do is do a little preparation. The manager module is not enabled by default, so we're going to turn it on. Next, we're going to set up our file systems. We're going to create a new CephFS volume called CephFS, as you typically do. And now we're going to prepare a subvolume group to hold 4 subvolumes. We're calling our subvolume group demos. And we're going to create 2 SMB clusters for this demo. So I'm going to create 4 subvolumes, 2 for each cluster. The first 2 will be for a user-based cluster, and the second 2 will be for a domain-based cluster. So now you have to bear with me as I type out all the commands. I do want to note that as we get to it, I will be supplying the -- mode option to the subvolume group command. This can be very this can be very helpful when you're setting up your initial permissions through the SMB Share. All right, so now Ceph is creating our 4 subvolumes. Next setup step will be to add some labels to our nodes. Now, this isn't strictly necessary to use SMB, but it's helpful for this demo because it will control exactly where the various servers will land in the Ceph cluster. So I'm going to add the first label to the first node in the cluster, and then I'm going to add this CS2 label to 3 other nodes in the cluster. Do a quick host ls, and you can see that the first label and CS2 labels have been applied to the hosts. Now we're going to set up our first cluster for real. We're going to use the Ceph SMB Cluster ls command just to show that there is nothing already on the system. And then we will start creating our cluster. We have to supply a name for the cluster, and we need to tell the system what kind of authentication we'll be using. So either user, which is users and groups locally defined, or Active Directory. When you're doing your self-defined users and groups, you can define them on the command line with this define user and pass command. We'll set up 2 users, both with unique passwords. And we'll also set a placement. Now, this is just the same kind of placement that you would use in regular Ceph ADM orchestration. And we're going to tell it to use the node labeled first. The system emits some of the JSON that is getting tongue-tied. JSON that is stored within the manager module. Now we're going to create some shares. The first share is called share1. We're going to point it at the volume cephfs, and we're going to tell it it's going to use the subvolume demos /uv1. So subvolume group /subvolume name. And a path within that subvolume. Now, we don't have any other paths within that subvolume, so you do have to just use / to start with. We'll start a second share named share2, which will be very similar to the first, but it'll have one additional wrinkle, and that is that we can supply a share name. So the share name can be anything that is valid for a share name in Samba or Windows. The earlier name is the share ID, which is a more restrictive token. So now we should have 2 shares on our cluster. It'll use the Ceph SMB show command to list the contents of our SMB configuration. Do show again with the resource type of Ceph SMB Share to show that you can limit the show command to showing resource types or resource by type and ID. We can also control what the output format of the show command is. So, using the orchls command, we could see that the system has started up our containers. So we'll jump over to a Linux host, and we'll use the very quick to use SMB client command to do a quick test. But don't worry, we're not going to only be on the command line for this demo. We'll provide a username and the IP of the first host in the cluster along with our share command. Going to upload a file to the share and list it. We'll quickly switch to the other user that we defined earlier just to prove that user authentication is in fact working. We see the file that we just uploaded, and then we'll move on to quickly show the second share we created. So that's that for the first cluster. Let's move on to our second cluster. This cluster will have a lot more features turned on. But we're going to use the declarative approach to create the cluster. I already set up a YAML file on the server, and I'm not going to go into every single thing here. I do recommend looking at the slide deck and looking at the YAML in the GitHub discussions linked in the deck. Two things I want to point out. This is using Active Directory and CTDB clustering. Domain setup in there, and then we have some public IP addresses. These are the addresses that CTDB will be using and that you should have your clients to connect to for failover purposes. We use the SMB apply command to send this YAML file to the manager module, which will process it and create the necessary cluster and shares. Now, setting up with a real cluster takes a bit of time. So you can see that Ceph Orch ls shows that we haven't started the cluster yet. In the meantime, I'll run a couple other SMB show commands. Once again, to show that the configuration is stored in various representations on the server. Now this YAML is actually round trippable, so if you lost your YAML file and you wanted to make a change, you could use the show command to get it, change it, and then submit it back to the server. Well, Ceph ADM still says that we haven't fully started our server, but I happen to know, since I pre-recorded the demo, that it's going to start any second now. So let's hop over to our Windows client. This Windows client is already joined to Active Directory, and we'll bring up Explorer, and we'll connect to our Active Directory enabled share. We'll just use one of the public IPs that was defined in the YAML file, and the share name. No, it uses the auto-enumeration. Do a quick test to connect to the other share. We'll do a quick test to make sure that we can write the file. And that's all handy-dandy. But don't forget, we already created a second cluster using users and groups. So we'll supply that IP address to Explorer. And in this case, it's not going to use Active Directory single sign-on, and we should be prompted for a new login. Once again, we'll supply the user we defined earlier in the demo. And there's the file we uploaded through the command line. So that's the basics on setting up clusters and shares with SMB. But since I hope some of you will actually try this out, I'm going to dig into a little bit on how the system actually runs these things. So first, excuse me, I want to show that there are multiple systemd services running for this one daemon concept within Ceph ADM. This relates to the sidecar concept that I mentioned earlier. So we have our SMBD, excuse me. And in addition to that primary container, we have an init container service, which runs and then exits before all of the other containers start. And then we have sidecars. And again, depending on what your configuration is, you may have 2 or more sidecars running on your systems. Each of these systemd services is launching a container through Podman or Docker. And you should be able to get the status of any of these services. The UUID, if you're familiar with Ceph ADM, the UUIDs are always changing, so unfortunately, you kind of have to deal with those long UUIDs all the time. Logging from our containers goes to a couple different places. The primary location is the systemd journal. You can specify the container name or the service name and see the logs in the journal there. You can also get the containers running from Podman or Docker and look at the logging there. However, those logs are lost when the containers are restarted. And finally, you can set up your systemd journal logging to take those logs and stick them in a log file or whatever your distribution does by default. There are a couple commands that you can run within the container that are helpful for debugging or just examining the system. You can use the podman exec command to get into the container and run the netconf list command to see exactly how we set up the Samba configuration. The SMB client command is located within our container images, so if you needed to do a quick and dirty connection test, you can do so within the container. And it's a good typo is a good demonstration of case insensitivity in SMB. Then you can use the Ceph ADM shell command. So I almost jumped ahead. So the communication between the manager module and the rest of the world is done through a specific Rados pool called .smb. There are two very important files or objects in this pool that we may want for debugging purposes. You can use the Rados command to get these files. So here I've listed the pools, I've listed the contents of one of the pools, the SMB pool, and now I'm going to fetch one of the objects. I'll fetch the other object too. The config object contains the configuration that we passed to Samba CC, which will then translate it into a Samba config for us. These are all JSON. I'm going to use Python here to make it a little bit more readable. It's Python 3. See, I make a lot of typos. This is one reason I didn't do this demo live, because you just watch me make so many typos. But anyway, the important part is that that configuration shows what Samba CC is, what the manager module is feeding into the containers. So last but not least, we're going to delete one of our clusters just for fun. The other reason we're doing it, not just for fun, is to prove that the clusters are independent of each other. You can have one AD, one non-AD. You could have one AD joined to a certain domain and another joined to a different domain. There is one item that I will talk about in the future features section where we can't co-locate, but if your Ceph cluster is big enough, we can have multiple SMB clusters operating independently on the system. So anyway, we've deleted one of our clusters. You can see that the state there in the status has been removed, and you can see from the Ceph Orch LS output that the cluster has indeed been removed. So that is the end of the pre-recorded demo. So we'll just jump back to the slides and try to wrap things up. Hey, Windows. Okay, so thank you for watching the demo. We'll wrap up by talking about what we're currently supporting, what we're going to support, and some maintenance status of this feature. So, we support Active Directory. We support clustering with CTDB. We export some Prometheus-compatible metrics. We have support for multiple logical clusters, as I just mentioned. You can supply the system with share access restrictions. These aren't permissions that you store in the file system, but they are permissions that allow certain users to connect to a share, say as read-only, read-write, or with special admin privileges. Then there's a special feature, config overrides, which allows you to put in your own SMB conf options after you put in a special disclaimer key. And that's because once you do that, we can't help you. But you can always use that to give us a tracker ticket and say, this worked for me. So some of our near-term plans are to add dashboard support. We're also actively working on adding performance and scale to the system. Samba uses a forking model so that every time a new connection is created, Samba has a new child process. This creates a new connection to Cephfs using libcephfs. This is a particularly memory-hungry operation. So we have a PR in progress that provides a new libcephfs proxy such that each SMBD talks to the proxy, and the proxy actually creates the true Cephfs connections. We're also actively working with the Cephfs team to add case insensitivity. I think that was even mentioned in the keynote earlier. And then, part of the point of this talk is to get people interested in this feature and to start trying it out and to report bugs so that we can fix them. Some of our longer-term plans include improving CTDB scalability, supporting transparent failover with CTDB, possibly expanding some of the Active Directory configurations that we support, allowing multiple containers to run on a single node, continued improvements to Ceph's VFS module. One of my colleagues is currently adding asynchronous support to the module. And then the biggie is concurrent SMB and NFS on the same subvolume. This is something that we discourage today through a feature called earmarking, where the subvolume gets tagged as belonging to either NFS or SMB. Someday, in the not too distant future, we may support SMB and NFS on one subvolume. And of course, this isn't everything. So, our plan is to make this a fully supported feature on Ceph with the Tentacle release. The code is currently on main, and once Tentacle branches are available with builds, we would really like folks to try it out, give it a try, report issues, make feature requests, and so on. I've linked to the Ceph mailing list just for convenience and the tracker. I would hope that you give it a whirl. Thank you very much. So I've been told that if we have questions, I can hand out a mic. So any questions? One sec. All my teammates came late. I was going to recruit them. But now they're sitting in the middle of the group, and I don't want to pester them.
Test. Okay. Thanks very much for the awesome talk. It seems quite
Thank you.
feature complete, so it looks quite good to me.
Thank you.
I sort of have a question regarding the creation of Samba shares, basically. So
Sure.
from what I saw, it's either something that you can do via the Ceph CLI, or you can do it using Ceph ADM. Do you have any thoughts on basically exposing this to the users, either via CSI or I guess like OpenStack or something like this, or something a bit further down the line?
That's very interesting. So I do have a plan at some point to expose the effective CLI API to the Go Ceph project, which already has support for doing that with NFS, and Ceph CSI uses that to create the NFS share. So yeah, I'm actually a maintainer of that project.
Okay.
So I just, when I get around to it.
Sure. Cool. Thanks very much.
Thanks. All right, thanks.
Thank you very much for this talk. This is very relevant for our use cases. You mentioned on the slide there was a possibility of joining to the AD, but you didn't really put any words on it. What's the status of that?
Okay, so that's a really good question. We support basic Active Directory joins with an ID map backend auto-rid, which basically takes the, if you have a domain forest, it kind of chops up the SIDs, uses the RID portion of the SIDs to map those all to IDs, and it's very automated and, what's the word I'm looking for, kind of pre-packaged for you. I had a conversation on the mailing list many months ago with someone who was interested in more flexible configs. Some people put their IDs in Active Directory. It's rarer than it used to be, but certainly want to hear from folks who might have that in their systems and want to use different ID mapping schemes or different support for Active Directory. Did that answer the question?
Yeah, thank you.
Great.
Thank you. It was a really great talk. Is there any support for LDAP authentication for Samba user authentication, or is that planned in the future?
So currently, we're only looking at true Active Directory. We've tested it with Active Directory, I've got Samba team members here in addition to myself. I shouldn't call the Samba AD not real. The alternative implementation and the standard implementation in Windows. Something like 389DS or OpenLDAP, we haven't really thought about supporting. But, you know, tracker tickets are easy to make.
Thank you.
Anyone else? All right. Thank you, everybody. I really appreciate it.